Hi, Math 2 students, and welcome to your lesson on piecewise functions. So yesterday we kind of worked on some function notation, and this warm-up is a review of that, all right? So I'm gonna go ahead, I'll do one of these and you guys could finish it up. So let's go ahead. It says evaluate the function for the indicated values. So they want us to do f of 2, so you're gonna plug 2 in for x into f of x. So you're gonna do f of 2 would equal, then you do 3 times 2 minus 2, which would give us 6 minus 2, which should be 4. So f of 2 equals 4. Then we have f of 0. So again, you're going to plug in 0 for x. And we have f of negative 2. You're going to plug in negative 2 for x. All right. So for number 2, it says graph the two linear equations on the same plane below. So first off, let's talk about linear equations. The one very common useful form of a linear equation is slope-intercept form, which is y equals mx plus b. M is your slope, and b is your y-intercept. All right, so if I wanted to graph this first one, you always want to, I would recommend, I should say, to start with the y-intercept when it's in this form. So that tells me where the line hits the y-axis. That's what that number tells me there. So that number is a negative 4, so that means that my line is going to hit, and actually I'll highlight this in blue so we know which one's which. So that tells me that my line's going to hit at negative 4 on the y-axis. Like 1, 2, 3, 4. It's going to hit right there. All right. And then my slope here is 1. All right. When there's nothing in front of the x, it's an implied 1. Since this one, oh, sorry, it's negative 1. Since it's just a negative sign, that means that it's going to be negative 1. So I'm going to go down, down 1 over 1, down 1 over 1. And those are my points. All right. So we'll go ahead, connect them, and that would be my line there. Then we've got the other line. My y-intercept is 1, and my slope is 2. Okay, so that means that I'm going to go up 2 over 1, up 2 over 1. Ooh, and I should graph that in red, right? That's the whole point. I did that. So we're going to start off at 1, because our y-intercept is 1. Then we're going to go up 2 over 1, up 2 over 1, up 2 over 1. And that would be my line there. I guess we probably should add arrows, right? All right, and that would be those two lines graphed on the same equation. All right, so now let's talk about what a piecewise function is. If we want a function to behave differently depending on the x values, we need a piecewise function. A piecewise function is just a function that uses more than one equation to describe its behavior. When we graph piecewise functions, we are really graphing different pieces of different lines. All right, so we're going to go ahead and try example 1 here. So first off, with a piecewise function, like it said here, it's a function that uses more than one equation to describe its behavior. And specifically with piecewise functions, it tells you when that part of the function holds true. So basically, for f of x here, when x is less than 2, so when you have an x value that's smaller than 2, you're going to use this function. When you have an x value that is greater than or equal to 2, you are going to use this function. So this part tells you which function you should be using. So for letter A here, it says f of 1. Well, that means we have to plug 1 into this function. But we have to figure out which equation do we plug it into. Is 1 less than 2, or is it greater than or equal to 2? 1 is less than 2. So we're going to go ahead and use this function. We do 2 times 1 minus 5. We end up with 2 minus 5, which is going to give us a negative 3. Then for B, it says f of 2. So we're going to go ahead and plug 2 in. Now again, we have to decide which function do we use here. Well, is 2 less than 2? No, it's not, right? 2 can't be less than itself. Is 2 greater than or equal to 2? Yes, it is. It's equal to, right? 2 is equal to 2, so the greater than or equal to symbol will work there. So that tells us we're going to use this function. So we do 1/3 times 2 plus 1. All right? We end up with 2/3 plus 1. And there are many different ways you could write this. I am going to write this as a mixed number. So when you go into your calculator and add 1 plus 2/3, you will end up with 5/3. All right. How did I do that in my head? Well, 2/3 plus, and you could change 1 to 3/3, right? That's how you would end up with 5/3 if you're curious on how you would add those fractions in your head. All right. So that is your answer to number 2. My handwriting is really bad there. Holy smokes. 5/3. A little prettier. All right, so now we've got C, which is f of 3. So we're going to go ahead. We have to decide, well, when do we use this function, right? Or I should say, which equation do we use? So if we look, f of 3, well, that's going to be the second equation. How do I know that? 3 is greater than or equal to 2. Okay, so that tells us we have to use this equation. So we have 1/3 times 3 plus 1, which is going to give me 1 plus 1, which is 2. So now let's go ahead. We'll try the next one. It's a different function here. All right. So let's go ahead. We've got x squared for x values less than -4. And then we have negative x plus 2 for x values greater than or equal to -4. So again, when we plug this into the function, we have to figure out, well, which equation is going to work for -6? -6 is less than -4. Right? It's smaller than. So that tells you you're going to use this equation. Excuse me. So we plug that in, and we would get -6 squared, which should give us a 36. Sorry for coughing. So then now we've got f of -4. So which equation do we use? Well, -4 is not less than -4, right? They're equal to. And since this is just a less than symbol, that doesn't work, right? But the equal to symbol is going to work. So we're going to say -4 is greater than or equal to -4 because it's equal to. So we plug that in. We do -4 plus 2, which is going to be 4 plus 2, which gives us a 6. All right, awesome. So now we got our last one here. We've got f of -2. So again, we have to figure out, well, which equation is going to work for -2? Is -2 less than -4? No, right? -2 is bigger than -4. Is -2 greater than or equal to -4? Yes, it is. So we're going to use that second one. So we're going to do -2 plus 2. We end up with a +2 plus 2, which is going to give us a 4. All right, so that is how you evaluate a piecewise function, right? That's what we did on the, function notation worksheet, right? You had to evaluate those given functions. So that's exactly what we just did. Just the only thing that was different was we had to decide which function's going to work for that x value. All right, so now let's go ahead. It says graphing a piecewise function. All right. So I kind of want to take you guys back to middle school. I'm sure you guys did this in middle school at some point where when you, if you were to graph just this is kind of unrelated to the problem, but in middle school, if you were asked to graph x is less than or equal to 1, you'd put a 1 there. And these guys always told you to use a filled in dot, right? And then you would have drawn your arrow that way. Hopefully that's kind of bringing back some bells. Bringing back some memories. And then for these other one, right, when you have those guys are an open circle, right? So then at 1, we'd have an open circle, and our line would go this way. So I'm just bringing back the idea that when you have the equal to symbol, you need to use a filled in circle. When you have a less than symbol or greater than symbol, you would use an open circle. All right. And that's going to ring true for these kinds of problems. All right, so we're going to go ahead and actually graph these now. Now, there's two different ways to graph these. I'll go ahead and we'll use both methods. How does that sound? So the first method is going to be using a table. So you have your x values and your f of x values, right? Now, to pick out which x values I'm going to use, I'm just going to look at my table, my graph here, right? It starts at -10. So just pick numbers, you know, that are going to fall within this range here so that you can graph them. So let's do -10. We will do, how about -5? You can do a -2. 0, I think it's always good to do 0 because that gives you your y-intercept. And then one thing I want to point out, if you do choose to use the graphing method, you should always put the point that is used to kind of define the piecewise function in your chart. So this is going to be a 1, and then let's do, how about 4, and we can use 10. All right, so we got a lot of work to do. We got to plug all these values in to get our y values. So if we want to plug in -10, we have to decide which function we're going to use, because this is our, I should say, which part of the function we're going to use. So if we look, -10 is going to be less than or equal to -1, right? So that tells us we're going to use the first function there, and we have 2 times -10 minus 1, which is going to give us -20 minus 1, which is -21. All right, so that's actually going to be off the chart, not going to be super helpful for us. Now we'll go ahead, we'll try our -5. So we've got we're going to do 2 times -5 minus 1, which gives us -10 minus 1, which is going to give us a -11. That's off the chart, but that's doable. We can at least graph that one. Then we've got a -2. So again, a -2 is going to be less than -1. So that we're going to use that first function there. All right. So then we're going to go ahead. We've got 2 times -2 minus 1, which gives us a -4. We end up with a -5. All right. Now we've got 0. So again, we have to figure out, well, which function are we going to use for 0? Again, 0 is less than or equal to 1. So we're going to use that first function. So we're going to do 2 times 0 minus 1 gives us 1. Now we've got 1. And this is where it gets, oops, didn't mean to do that. This is where it gets a little tricky, right? We have to decide which function are we going to use at 1. Okay? The equal to tells you which one you're going to use at 1. So since it's equal to 1, we're going to use the first function. All right? So we're going to do 2 times 1 minus 1. It's going to give us, oh my goodness, I guess I made an error here. This should have been 0 minus 1. Oopsies. Right, and that should be a -1. Sorry, guys. So just slap a negative right there. I clearly did my math wrong there. So we get 2 minus 1, which that's going to be 1. All right. So we should be good there. All right. So now let's go ahead. We're going to plug in some more values. So we've got +4. Well, at this point, we've crossed this. We've crossed the line here, right? Now we are going to be bigger than 1, right? 4 is bigger than 1. So we have to use the second equation. So we're going to do negative, and then our x value, which is 4, and then +3, which is going to give us a -1. Then we're going to go ahead and plug in 10. All right, so 10, again, is greater than 1. So we're going to plug it into that second equation. So we get -10 +3, which is going to give us -7. So now at this point, we can go ahead and graph. Unfortunately, we can't really graph this point because it's way off the chart. We can graph -5. It's going to get us to -11 here. And then we get -2, -5. 0, -1. And keep in mind that this was kind of the point, right? This is the point where it switches. So that's kind of a really important point. We're going to talk about it. So we know that that happens at 1, 1. Okay, so it goes through the point there at 1, 1. Now, we have to decide, are we going to use an open or a closed circle? All right. So at this point, what we would do here is we would use a closed circle because this one has a equal to sign. Now at this point, this is where we switch over to the other equation. So we actually are going to want to figure out at 1, what would this be, right? So if I plugged in 1, I would get -1 plus 3, which is going to give me a 2. All right, so I get -1, or I'm sorry, we get +1, comma 2. So that tells me that the second function starts here. But instead of using a closed circle, this one is greater than or equal to. So that tells me I need to use an open circle. And I'm going to put an open circle there. All right. So it's important at that switch point, you need to plug into both equations. All right. This is the actual value of the function at 1. But you have to show, right, that this one's picking up right after it. So that's how you show it with the open circle. All right. Then you can go plot the other ones. We got 4, -1. And we've got 10, -7. So we'd be down here. All right. So then we can go ahead and draw in our lines here. Ooh, whoa. And those would be our functions. And notice, right, that these are 2 separate lines, kind of just like chopped off here. If this wasn't a piecewise function, this line would continue this way, and this line would continue this way. But since this is a piecewise function, those lines they each stop at 1, okay? And that would be our answer. All right, so let's go ahead. We will try it in a different way. We're going to use my second method here. And basically what that involves is it's just graphing like normal. So let's just graph this one like normal, okay? And I will warn you that you're going to have to do erasing. So use a pencil for this. So if you need to stop and go grab a pencil, go do that. Because this is how I like to graph them. But, you know, figure out what method works for you. So we'll go ahead. We know our y-intercept is -1 for this one. And our slope is 2. So we're going to go up 2, over 2, up 2, over 2. We go down 2, over 2, down 2, over 2. And this will get us a nice line. We should be able to extend in both directions. All right. Then we'll go ahead and we'll graph the second one. Right? So we graph our y-intercept first, which is going to be at 3. And our slope is -1. So we're going to go down 1, over 1, down 1, over 1. So we keep going until we get our line here, which we can then extend in this direction. Now, if this wasn't a piecewise function, we would have graphed these lines perfectly and we'd be done. But this is piecewise, so we have to kind of restrict them, show where they end. All right. So get your erasers out. Let's see. I got to make sure that this only does partial. Oh, here we go. See, partial. There we go. So now we know that this first equation only holds true until 1. So basically, after x equals 1, that first equation here is no good. So we have to erase it. All right. So we erase that. And at that specific point now, we have to decide, is it going to be an open circle or a closed circle? All right. And this tells us that this is going to be a closed circle. All right. So we'll go ahead. We make this a closed circle and we're done. Now, we're going to go ahead. We got to erase for the second guy here. So this guy only holds true for x values greater than 1. So we have to erase the part of this that is x values less than 1, which gets us to this point here, right? And at 1, we have to decide, is it an open circle or a closed circle? Well, there is no equal to sign, so it is open. All right, so we'd put an open circle there, and that would be your answer. So that was, again, same problem, just different way to graph. That one clearly involves erasing. That's how I like to do it. But if you like charts, go for it. All right, so example 4, writing a piecewise function. All right, so for this one, you guys have to come up with the equation. All right, so first off, we have to figure out kind of, if we're writing this, right, we have f of x. We're going to do our little swirly brackets. All right, we have to figure out, well, first off, what's our switch point? Where do the two functions switch up? This happens at 2, all right? So we know that this, you know what, we'll kind of color code it. We've got our red guy here, all right? He's going to hold true when x is less than 2. And since he's open, he's going to look like that, right? So we're going to say, well, this guy is going to hold true when x is less than 2. Then this other guy, he is going to hold true when x is greater than or equal to 2. Why is he equal? Because he's a closed circle, all right? So when x is greater than or equal to 2, that blue guy is going to be what we use. So now let's go ahead and come up with the equations. So this first one goes through the y-axis. So it actually makes things a heck of a lot easier, right? We can put it in y equals mx plus b right away. All right. So if I look here, my b is going to be -1. That's our y-intercept. All right. So we'll say for... Oh, I should be doing this in red. Sorry. Here, let's see. I should be able to just style, make it red. All right. Sorry. So our intercept here is -1. So we'll say, okay, well, b is equal to -1. Now we got to find our slope, right? Obviously, it's going to be negative. And our rise is 1. And we go back 2. So we're going to have -1/2. So the equation of this line is going to be y equals -1/2 minus 1. Or 1/2 x minus 1. And that would be how we would define the red line. Now let's go ahead and do the blue line. So first off, you could count the slope. This one's just going to be a +1. It goes up 1 over 1, up 1 over 1. So we've got our slope is 1. But now we got to go ahead and we got to figure out, well, there's kind of 2 ways we could do this. We could extend the line and figure out what the y-intercept is. But let's say that's not an option. We're just going to pick another point. So how about let's use the point 2, 1, right? Because that's that point right here. We're going to plug that into point slope form. So we got y minus y1 equals m times x minus x1. We did this on the homework where we went over function notation, right? We learned how to use this equation and come up with an equation from a line, from the slope, and a point. So we've got our m1 or m, which is our slope, and then we've got our point, which is 2, 1. So we're going to go ahead and plug those in, right? That's going to go there. This guy is going to go in for x1. And then this guy is going to go in for y1. So we end up with y minus 1 equals 1 times x minus 2. Then we can go ahead. We would distribute this 1. So we just get y minus 1 equals x minus 2. Because 1 times x is x. 1 times -2 is -2. Bring the 1 over. You get y equals x minus 1. So that is going to be our blue equation. X minus 1. Now, we could go ahead and kind of extend this guy, and you would see that he does go through his y-intercept. If he continued on, which he doesn't, would be -1. That's another way you could do that, find the slope, and then just find the y-intercept by doing that. All right? So that is how you would write a piecewise function.